Hi, this is Dr. Pranjali Sharma, and in this video lecture I am going to teach you partial differentiation. So what is partial differentiation? Let z be a function of x and y both, means z is depending upon more than one independent variables x and y. Then if we have to differentiate del z by del x, means if we have to differentiate z with respect to x, then we have to treat y as a pure constant. Actually we are ignoring the y part. Similarly, if we have to find out rate of change of z with respect to y, that means if we have to differentiate z with respect to y, then we have to ignore the x part, and to ignore it we consider x as a constant. In similar manner, we can find higher order derivatives like del square z by del x square, which will be del by del x of del z by del x. It is also written like zxx. Similarly, del square z by del y square means del by del y of del z by del y. It is also written like zyy. Similarly, we can find del square z upon del x del y, which will be del by del x of del z by del y. It is also written like zxy. Similarly, we can find del square z by del y del x, which will be equal to del by del y of del z by del x, which is also written like zyx. And do remember, for any function, del square z upon del x del y is always equal to del square z upon del y del x. That means zxy is always equal to zyx for any z, which is a function of x and y. Similarly, if u is a function of x, y and z, then it can be differentiated with respect to x, y and z as well. Means we can find del u by del x, del u by del y, del u by del z, and higher order derivatives. And the only key point is, when we are differentiating with respect to x, then we have to treat other independent variables as constants. Actually, we are ignoring y and z part, and we are studying rate of change of u with respect to x. So, by an example, I will show you how can we differentiate partially. So, let's see an example. We are taking an example and we'll see how can we differentiate partially. U is x square plus y cube plus z, and we have to find out del u by del x, del u by del y and del u by del z. So del u by del x will be, when we differentiate x square, it gives us 2x, and these two are treated as constants, so they will be 0, 0. Therefore, del u by del x will be twice of x. Similarly, del u by del y. So, when we are using y, then x and z both are treated as constants. So this will be a 0 and differentiation of y cube will be 3y square and the differentiation of z will be 0, so it will be. Similarly, you can easily find del u by del z. This time x and y will be constants, so these values will be 0, 0 and differentiation of z with respect to z will be 1, so the value is 1. We will solve some more examples, so I am taking one more example. Having more independent variables. Let u is e to the power x, y, z. Means u is depending on x, y and z. And the question is find value of del cube u upon del x, del y, del z. We all know that since del cube u upon del x, del y, del z means del by del x of del by del y of del u by del z. So we have to find out, since u is e to the power x, y, z, and when we partially differentiate with respect to z, I am starting over here. So del u by del z will be, since x, y are constants, therefore it will be e to the power x, y, z into constant x, y. So this is our first derivative. Next, to differentiate it with respect to y. So next we partially differentiate it with respect to y. So the left hand side will be del square u upon del y del z by definition, and here we have to use the product formula, which is differentiation of f1 into f2 will be f1 differentiation of f2 plus f2 differentiation of f1. So this is first function and this is second. So first function differentiation of second, so it will be e to the power x, y, z, and this time with respect to y, x and z are constants, so into xz. First function differentiation of second plus second function differentiation of first with respect to y, so it will be into x. So e to the power x, y, z can be taken as common, and under bracket it will be x square yz plus x. Next, to differentiate one more time, and that is with respect to x. So we differentiate the above line with respect to x this time. So we have an equation, and that is del square u upon del y del z is equal to e to the power x, y, z into x square yz plus x. Now differentiate it partially with respect to x this time. So we again use product formula. This will be first function and this will be a second function, and we use the product formula differentiation of f1 into f2, which will be f1 differentiation of f2 plus f2 differentiation of f1. So let's see. First function differentiation of the second function. So differentiation of second function will be plus second function differentiation of first function. So if we differentiate this, it will be e to the power x, y, z, and with respect to x, this time y and z are constants, so it will be into y, z. So we can take e to the power x, y, z as common, and it will be 2xyz plus 1 plus x square y square z square plus x y z. So since these two are like terms, they can be added, so it will be e to the power x y z and 1 plus x square y square z square plus 3xy z. So this is our final answer, and when we differentiate with respect to x, the left hand side will be del cube u upon del x del y del z. So we have found the value of del cube u upon del x del y and del z. So this is all about how can we differentiate partially if a function is depending on one or more independent variables. So in next lecture I will show you some applications of partial differentiation. Thank you.